The repetitive stimulation by using the example of the accessory nerve. The repetitive stimulation, which is also known as the myasthenia test, is a measurement for the diagnosis of myasthenia gravis. This is a neurological disease that is characterized by stress-related muscle weakness. In this instance, the examination will be demonstrated on the accessory nerve. However, it should be noted that it is also possible to examine all other motor or mixed nerves. The disease begins in the proximal musculature and spreads toward the peripheral. Therefore, it is useful to record at both a proximally small and a peripherally large muscle. The active electrode is placed directly on the trapezius muscle, which can be felt out when the patient constricts the muscle by pulling his shoulders up. The inactive electrode is placed on the clavicle. The grounding strap should be moist and it must be attached to the upper arm. The accessory nerve is stimulated laterally in the neck behind the sternocleidomastoid muscle. The exact stimulation position can be determined by turning the patient's head to the opposite side. The stimulus intensity increases slowly until the amplitude of the potential does not rise any further. To ensure that all nerve fibers are stimulated, the stimulus intensity is increased by another 20%, which means that the supramaximal stimulus intensity is reached. Following this, 10 automatic stimuli are triggered consecutively. These will enable you to observe an obvious muscle contraction in the patient. Following measurement, the patient must maximally constrict the muscle for approximately 2 minutes. In addition, he should move his shoulder up against a resistance. During the phase of muscle contraction, it is recommended to keep the stimulation electrode at the neck to avoid a repositioning of the stimulation position. Subsequently, the measurement is repeated with the same stimulus intensity as was the case at the first stage. Displayed in the results table are the amplitude values of the individual measurements and the decrement, that is, the amplitude reduction in percentage form. The amplitude decrease is shown in a descriptive manner in the graph.